Hi, my name is Brianna Jenkins, and this is AP Statistics Quideo 1. The first question we will start with is the basic question. The basic question reads, in 1993, Forbes magazine reported the age and salary of the chief executive officer or CEO of each of the top 59 small businesses. Here are the salary data rounded to the nearest $1,000. Construct a histogram for these data. Describe the shape, center, and spread of the distribution of CEO salaries. Are there any apparent outliers? In order to construct your histogram, you must first get the 5-number summary. In order to get your 5-number summary, you must first type all your data into your calculator. First, you go to Stat and Edit. Then you go to L1 and type in all your data. Next, you go to Stat, Calc, and you go to 1 var stats and type in enter 3 times, and you get your 5-number summary. The 5-number summary that you get from your calculator reads a mean of 404.169, a standard deviation of 59, a minimum of 21, quartile 1 being 250, a median of 350, quartile 3 being 543, and a maximum of 1,103. After you get your 5-number summary, you must determine a distribution spread for the data. I went by hundreds for mine. You then determine how many numbers fall in each category of 100. From 0 to 100, there's 2 numbers. From 100 to 200, there's 4 numbers. From 200 to 300, there's 18 numbers. From 300 to 400, there's 14 numbers. From 400 to 500, there's 4 numbers. From 500 to 600, there's 6 numbers. From 600 to 700, there's 3 numbers. From 700 to 800, there's 3 numbers. From 800 to 900, there's 4 numbers. From 900 to 1,000, there's 0. From 1,000 to 1,100, there's 0. And from 1,100 to 1,200, there's only 1. Next, you draw out your histogram graph. First, you label the y and x-axis and give your graph a title. Then you draw your graph based on your distribution information. The center of this data is approximately 350 because 50% of the data fall above 350 and 50% fall below 350. The shape of this data is skewed right because most of the data fall in the upper end of the graph, making it skewed to the right. The spread of the data ranges from 21 to 1,103. Due to about 50% of the data being in the upper end, it affects the overall spread. The outlier affects the way the distribution is spread out over the graph. In order to determine your outlier, there's a formula you must use. You take the Q3 minus Q1, which is 543 minus 250, to get you 293. Then you take the Q3 plus 1.5 times 293, which will give you 982.5, which is the upper cutoff for your outlier. Next, you take Q1 minus 1.5 times 293, which will give you negative 189.5, which is the lower cutoff for your outlier. The only outlier that falls out of these cutoffs is 1,103. Based on the formula, the outlier is 1,103 because the upper cutoff for outliers is at 982.5, making 1,103 falling behind the cutoff. Next, we will work on the advanced question. The advanced question reads, in 1864, a published paper provided chest measurements in inches of 5,738 Scottish militiamen. The table below summarizes the data. The summarized data shows the chest sizes and the counts falling in each chest size. First, make a histogram of the distribution. Then describe the shape, center, and spread of the chest measurement distribution. Also, why might this information have been useful? First, you must separate your distributions into sections in order to create your histogram. The sections include 32 to 34, which have 3, 34 to 36, which have 99, 36 to 38, which have 605, 38 to 40, which have 1,822, 40 to 42, which have 2,013, 42 to 44, which have 1,028, 44 to 46, which have 142, 46 to 48, which have 25, and 48 to 50, which have 1. In order to make an accurate histogram, you must divide the count by 300s in order to make your graph. Next, you draw your histogram. First, you must draw and label your x and y axis and label them. Then you give your graph a title. Next, you draw your histogram based on the distributions used for each section. After creating your graph, you look at the shape. The shape is relatively symmetrical because it is approximately even on the first 50% and the second 50%, making it look even on both sides. The center of this histogram falls right down the middle, making it approximately 40 inches for this graph. The spread of this data ranges from 33 to 48 due to about half of the data in the upper 50% and half of the data in the lower 50%, making the spread to be even. This information might be useful to show the ranges of uniforms or shirts to get for these militiamen. It could show you what sizes to get the most of and what not to get that many of. Lastly, we will work on the AP question. The AP question reads, as a part of the United States Department of Agriculture's super dump cleanup efforts in the early 1990s, various sites in the country were targeted for cleanup. 3 of the targeted sites were River X, River Y, and River Z had become contaminated with pesticides because they were located near abandoned pesticide dump sites. Measurements of the concentration of aldrin, a commonly used pesticide, were taken at 20 randomly selected locations in each river near the dump sites. The box plots shown below display the 5-number summaries for the concentrations in parts per million of aldrin for the 20 locations that were sampled in each of the 3 rivers. First, compare the distributions of the concentration of aldrin among the 3 rivers. When it comes to all 3 rivers, River Z has the smallest amount in it compared to River Y and River X. River X has a shape that is skewed left, while River Y is relatively symmetrical and River Z is somewhat skewed right. For all 3 box plots, 9 is a potential outlier compared to all of them. River X has the highest center compared to River Y and River Z, and it also has the widest spread of data compared to River Y and River Z, referencing to its size. Next, the 20 concentrations of aldrin for River X are given below. Construct a stem plot that displays the concentrations of aldrin for River X. Next, you draw your stem plot from the 20 pieces of data given and label it. Then you fill in your data for your stem plot. After your stem plot has been graphed, you must make a key to indicate what your stem plot means. 3-4 means a 3.5 concentration of aldrin for River X out of 20 concentration samples taken. Lastly, Part C reads, describe a characteristic of the distribution of aldrin concentrations in River X that can be seen in the stem plot but cannot be seen in the box plot. A characteristic that can be seen in the stem plot but not in the box plot about the distribution of aldrin in the river is all the distributions found in the river instead of just a range of numbers from the distributions. It gives you more information.